Let's depict the Lewis structure of CH4, also recognized as methane. To accurately depict the Lewis structure of CH4, follow these steps. Begin with a rough sketch. Illustrate the chemical bonds between the atoms. Identify and mark lone pairs on the atoms, if any. Ensure each atom, including the central one, has a complete octet. Complete the process by calculating formal charges, aiming for a stable Lewis structure with the least formal charges possible. Before sketching the rough diagram, we will do two things. First, calculate the total number of valence electrons and then determine the central atom. The total valence electrons in CH4 are calculated by summing the valence electrons of each atom. Carbon, a member of group 14, possesses 4 valence electrons, and each hydrogen, a group 1 element, contributes 1 valence electron. With 1 carbon and 4 hydrogen atoms in CH4, the total valence electrons calculation is 4 for carbon plus 1 for hydrogen multiplied by 4, resulting in a total of 4 plus 4 equals 8 valence electrons for CH4. When selecting the central atom for CH4, prioritize placing the element with the lower electronegativity at the center. Although hydrogen is present in CH4, designating it as the central atom is not valid, as the central atom typically forms bonds with at least 2 other atoms. Since hydrogen generally forms single bonds due to having only 1 valence electron, it is less suited for the central role. Therefore, in the case of CH4, consider positioning carbon at the center with 4 hydrogen atoms arranged around it. 2 electrons represent a single chemical bond. Therefore, we will use 2 electrons on the left side to indicate the chemical bond between carbon and the left hydrogen. Similarly, place another 2 electrons on the right side to represent another chemical bond between carbon and the right hydrogen. Additionally, use 2 for the top hydrogen and 2 for the bottom hydrogen. In this way, 4 chemical bonds are shown with 8 electrons, utilizing all 8 total valence electrons. You can observe that the duet is complete for the 4 outside hydrogen atoms, and the octet is satisfied for the central carbon atom. Both the duet rule and octet rule are met. Now, we just need to check the stability of the structure by calculating the formal charges. This is the formula we can use to calculate formal charges for the CH4 Lewis structure. Formal charge equals valence electrons minus, non-bonding electrons minus, half times bonding electrons. Just input the data and allocate the values to obtain the formal charges for each individual atom. For carbon atom, valence electrons are 4, non-bonding electrons are 0, and bonding electrons are 8. So the formal charge will be equal to 4 minus 0 minus half times 8, which equals to 0. For each hydrogen atom, valence electrons are 1, non-bonding electrons are 0, and bonding electrons are 2. So the formal charge will be equal to 1 minus 0 minus half times 2, which equals to 0. The formal charges of both carbon and hydrogen atoms are mentioned, and it is evident that the current structure is stable, as formal charges on each atom are 0. Therefore, this structure is the preferable stable Lewis structure of CH4. To represent a pair of bonding valence electrons, we can simply draw one horizontal line. Since there are 4 pairs of electrons surrounding a carbon atom, draw 4 horizontal lines one by one, indicating that carbon is single-bonded with 4 hydrogen atoms. So, that's the Lewis structure of CH4. If you found this breakdown helpful, like the video, share it with your friends, and subscribe to the channel for more chemistry content.